Welcome to a KeySmash Studios tutorial. In this video, we're going to be polishing our interaction areas that we created earlier on in this series. We're going to have the player's rotation change to face the object of interest. So for instance, right now, if I go into play, and then I go over to a tree and just click F, I stay facing away from the tree, and so when we add animations to make it look like I'm chopping the tree, it'll be a little weird because I'll just be chopping at thin air. So I want to have my player face the tree so that way it looks and feels more realistic. As you're watching, if you find this video helpful, please remember to like and subscribe. So in order to have our player face the object of interest, we need to start by opening up my character. And within my character, we need to go to the header, and we need to add a new including. So it's going to be include Kismet / Kismet math library. And we're going to use this so that we can access an Unreal function that will do the math for us, so that way we don't have to calculate the angle that our player needs to be in order for it to be facing the tree. And now what we want to do is scroll down to our canInteract function, and we're going to add another parameter. This one is going to be an F vector. And what we'll end up pulling in from this is the location of the interaction area. So we're going to call this face point, as this is the direction that we need to be facing. And then we're also going to need to add a new property. So we'll go down here with our other properties that save this information of our interaction area for us. And we're going to do uProperty, F vector, and we'll call this look point. And we're going to use this to hold that passed in value, so that way we can calculate the angle needed outside of the canInteract function. So we can go ahead and save that, and that's all for our header. So now we'll go to our CPP. And first we need to go down to our canInteract function, and we need to add that argument. So it's F vector face point. And then just like these other things, we want to come in here and we want to say our look point is equal to our face point. So that way we can hold that face point value in a property that scope is bigger than just canInteract. And now we want to scroll down to our interact function, which is where we'll be doing this math. So that way we can face the object. And so the first thing we need is a temporary F rotator. So I'm going to do F rotator, and I'm just going to call it rot. And this is going to hold the returned value of the rotation we want for our player. And so in order to get that rotation, you want U Kismet math library. And then the function that does this for us is FindLookAtRotation. And this takes in 2 points, the start point, which is the player's location, and then the target point, which is going to be the location of our interaction area, also known as look point. So we're going to do getActorLocation. Again, for the start point of where our player is, and then for the target point, we just simply put look point. And now we need to set our player to this returned rotation. So we're going to do setActorRotation, F rotator. We want it to be 0 in the pitch, and then we want it to be the rots yaw in the yaw direction, and then 0 in the roll. We can go ahead and save that, and that's all we'll be doing for our character. Again, we created a variable that will hold in this new passed value of face point, so that way we can use this value inside of our interact function to determine the angle that our player needs to be to face the interaction area, and then turn their rotation so they're facing that direction. So now we can go ahead and go to our interactions CPP, because we call this canInteract function, and now there's a new parameter for it, so we need to add that parameter. And again, it's the face point, so we want to get the actor's location, And this is returning the vector of that specific area point to our character class. And then for when we've exited the area, we're just going to give it an f vector of 0, 0, 0. Which is essentially the null for our vector because we have to pass in a vector. The vector doesn't matter because it's not doing anything with the exited vector, so we're just passing in one that's at 0. And that's all we're doing for code, so we can go ahead and go back to the scene and compile. And now that our compile has completed, we can go ahead and test and play. And then as you can see, if I go over to this tree and click F to chop, my player rotates to face the tree. And the same is true with this little tree over here, so I'm facing the opposite direction, and it turns me all the way around to face the tree, so whenever I chop this tree, it looks and feels more realistic. So as a recap, we used Unreal's FindLookAtRotation function, and we passed in the player's location and the trigger box location, so that way we could figure out the player's needed rotation. As a side note, you want to make sure that your interaction area is centered on your objects, because you are finding the actual interaction area's location and not the object's location. So if your interaction area is not centered on your object, your rotation in relation to the object may not be as perfect as you want it. So just make sure that your interaction area is centered on the object that you're wanting to face. As always, I hope this video was helpful. If you have any questions or suggestions, feel free to leave them in the comments, or you can join our Discord and ask them there. We make videos here every Wednesday and Saturday, but we also stream games on Twitch Monday through Wednesday, so be sure to check that out if that interests you. We've released a game on the Google Play Store called Blast Off, and we've released an asset pack of kids' toys on the Unity Asset Store. Along with that, we've created a Patreon per the requests of some of our viewers. So if any of those things interest you, I'll provide the links for all of those in the description below, and be sure to check them out. Don't forget to like and subscribe. Thanks for watching. See you next time.